Hi everyone, I am Nora. Today I'm going to explain to you a small tutorial about how to solve ordinary differential equation first order with simulink. Since I am from chemical engineering department, I will explain for you an example from a chemical book. I bring the example from book called Principle of Chemical Engineering Process. Naif Qasim owns Dr. Naif Qasim, owns this book. The problem said in a sewage treatment plant, a large concrete tank initially contained. We have a big tank that its volume is 440,000 liter liquid, and it has some suspended solid around 1,000 kilogram suspended solid. To flush this material out of the tank, water is pumped onto the vessel at a rate of 40,000 liters per hour. So we have inlet to this tank, and the water used here to flush the solids out come at a rate of 40,000 liters per hour. This is the volumetric flow rate. And liquid containing solid leave at the same rate. So here we only inject a pure water, but it leaves with a liquid containing solids, but with the same rate, 40,000 liters per hour. Estimate the concentration of suspended solids in the tank at the end of 4 hours. What will be the concentration after 4 hours from proceeding this process? So we will start with the general mass balance. Change in mass by time equal to mass n, the inlet that come from the inlet of the tank, minus the mass that get out from the tank, plus generation and minus consumption term. Since we don't have reaction in this system, so this term will be 0. And our equation will be summarized to change in mass will equal to only Mn minus M out. Since we are dealing with concentration, we will change the mass to the concentration. We know that mass equals to the volume time concentration. Here it is, we will put the volumetric flow rate to be same units. Here the volume over time, here volumetric flow rate, which is volume over time. Cn and C out. Since we have inlet volumetric flow rate equal to the outlet volumetric flow rate, there will be a constant change in the volume. Also, as if you notice from the problem that I said, it's pure water only coming to the system with no solids. So, this term will Cn, we don't have any concentration, and so this term will be 0. Will have this term. So our final equation will be, since we said it's a constant volume, so volume will become out from the derivative. So we have V dC by dt equal to 0 minus V out times the concentration. And this is our differential equation. We can simplify it because in simulink you can't solve it like that. You should have the differential equation alone, so we will divide by the volume here. And you should notice that we should put the initial condition in the simulink to work properly. So our initial concentration at time 0 was the mass over the volume. Initially we had 10,000 kilograms of the solids, and the volume was 440,000 liters, and we got this number. Now we will move to simulink to solve it. After you open MATLAB, you go to simulink, and from this window here, you press on it, and you will get this. Window, and you can do new or open a folder. Let us solve our differential equation, which was dC by dt equal to minus V out times the concentration, everything divided by volume. To solve this problem, you should has an integrator. The integrator, you can find it from commonly used, if I'm correct, yes. Here is the integrator. This integrator is dc by dt. I will increase the font. So this is our dc by dt. Let us put this equation alone, then we will see what will happen. V out, we have its value 40,000 liters per hour. We will put it as a constant. Again, you go to commonly used. You can search play or with this, you will find many interesting things. Here is constant. This constant, double click on it and enter the value 40,000 yes, liter per hour. You should make sure that the units are consistent. This is our V out. I will enlarge the font. This V out is multiplied by minus. Either you put it here, which is good, it will accept it. Then times the concentration. How you can get these values although you need it? You should notice that the integrator will give us the output. This output is always equal to the derivative. What I mean is, if you have dc by dt, it will give us c. So we want c, but it's multiplication. We need a multiplication sign. Here we have product. You insert it here. You multiply the V out, and then we will multiply also by the concentration. But we have a division by V. In MATLAB, you can double click in the product, and you will have here number of inputs. We have 2. Delete it, and you can replace it by 2 multiplication, 1 division, or anything you want. So I will do 2 multiplication, and this is a division sign. So I get it here. I get the division sign. I need the division sign for the volume. So again, I will add a constant. Here is our constant. We will enter the value of the volume, which is 440,000 liters. Yes, it is correct. You can enlarge it to see the number. We will connect it to the division. Then the result from this one is the derivative. So the result will enter the integrator. How we can show the result? We should do it by 2 ways actually. The first way is you go to scope to have a draw for this graph, and you connect it to the outlet of the integrator. Sorry, yes, it is like that, and you delete this one. It's okay. Now we wanted 4 hours. This one is for the dt, and we need it after 4 hours. If you put 4 hours here, and then you do run, then double click on the scope. This graph is not clear. Click here to make it clear for you. You will notice that it is a wrong graph because we forget an important thing, that we did not put integrator. The initial condition. That I said it's 0.023, the initial concentration. Then again, it is here. After 4 hours, it is a decay. We will get 0.016 kilogram per liter of our product. That's all for this tutorial. Hopefully I will bring for you another tutorials which is more complex. Good luck and see you again.